Hi, and welcome to Next.js course. In this course, I'll guide you through some of the common and important concepts in Next.js. We are going to learn about styling, fonts, data fetching, and a bunch of other really important stuff in this video. For the package manager, I'm going to be using pnpm in this video. If you want to install pnpm in your system, you can simply execute this command npm install pnpm-g. This is going to install pnpm as a global dependency in your system. If you do not want to use pnpm, that is absolutely fine also. I will provide all the alternative commands along the way. Let's start by creating a fresh Next.js project. You can create a fresh Next.js project either from scratch by configuring everything on your own, or you can use a CLI tool like create next app. I'm going to be using the CLI tool only, create next app, in this video because it is going to save me a lot of time and it will set up my Next.js project with all of the sensible defaults. I'm going to execute this command pnpm dlx create next app, and let's use the latest version of this. Then we can specify the name of the project. Let's call this Next.js Foundations, right? Now, if you're using npm, make sure you replace pnpm dlx with npx. So the command for you would be npx create next app latest and then the name of your project. When I execute this command, this is going to ask me a bunch of questions like, would you like to use TypeScript? Would you like to use ESLint? I am essentially choosing all of the default options except this Tailwind CSS. I'm saying no to Tailwind CSS because I want to show you different ways of styling the Next.js application. Let's open this folder in the code editor now. First thing that I'm going to be doing is inside of this app directory, I'll go to globals.css file and I'm going to get rid of all of the CSS styles present in this file. And similarly, I will do the same thing in the page.module.css. I'll go to home page, which is this file page.tsx. I'm just going to replace the content of the home page with some simple JSX markup, as you can see over here. I will open the terminal, execute this command pnpm dev. If you're using npm, make sure you run the command npm run dev. This is going to start the development server for you, and then you should be able to access the application in this specified address, as you can see over here. One of the popular ways of styling your Next.js application is using something called as CSS modules. For example, if I want to style this home page, I can create a file called page.module.css, add my CSS styles to this page, and then in the home page itself, I can import these styles by doing something like this. And then I can do class name is equal to styles.main. So this main refers to the main class that we have created in our CSS. For example, if we take a look at page.model.css, you can see that this is the main class that we have created, and we have declared a lot of CSS rules inside of this class. So we are actually applying this class to this main element in the JSX, and this is how we do it. Similarly, I can apply styles to all of these elements. And if you take a look at this page in the browser, you'll notice that our styles are being applied correctly. If you take a look at this page.module.css file and notice the name of the classes that we have created. So we have created the main class, card class, title class. If I inspect my web page and try to find these classes, you'll notice that Next.js has either prepended or appended something, or have done both of the things to the classes that we have created. Next.js does this to prevent something called style collision. And style collision is the simple idea that one CSS rule overrides another CSS rule unexpectedly. So one of the benefits of using CSS module is that it prevents style collisions. And it does that by locally scoping the class names to the component in which you have imported them. Now here is something that does not exist in Next.js by default, but it will improve your developer experience by quite a lot. The way we write CSS is by using the kebab casing. That means if I want to write a class name like user message, I'm going to write it like this, right? Let's give this a font size of probably 4 rem and a color of, let's say, red. Okay. Now, if I want to apply this CSS class name in my page.tsx, the home page, let's create a para first of all, and then this is the user message. I can do something like this, class name, and this class name is equal to styles And since our class name contains a dash in the middle, so that is why we cannot use a dot operator to access that. We cannot do something like user dash message. This is not the valid JavaScript. So in this case, what we have to do is we need to use a different kind of syntax. Within this square brackets, we need to specify user dash message. So if you come over here, you can see that our styles are being applied. Now, if you're like me, I do not like this syntax, to be honest, because this is a little bit harder to write as compared to something like styles.userMessage, right? So what if we could do something like this? Because this is the valid way of writing JavaScript. You write JavaScript variables in camel casing, but in CSS, you write these names in kebab casing. Well, we can actually do that. We can actually do this by modifying the next configuration file. We can just modify the underhood webpack configuration so that it automatically converts the CSS class name that has kebab casing to their camel cased version in JavaScript. And here's what we are doing in this code. We are essentially finding all of the rules that has something to do with CSS loader, and then we are merging all of those rules in a single array. We are looping through this array and checking if the options.modules exist. And if it exists, we are setting its export locals convention option to camel case. So this is actually an option in Webpack that will automatically convert the kebab cased CSS class names to camel case version. That means by adding this piece of code, if I take a look in the browser, you can see that our styles are being applied. And let me just show you this again. If we go over here, go to page.tsx, notice how I'm applying styles over here, styles.userMessage, and this user message is in camel casing. But if we take a look at the CSS file, you can see that this follow the kebab casing. Perfect. By the way, the credit for this code goes to Izachok. I apologize if I'm pronouncing the name incorrectly. So this is how you can use CSS modules. What if you do not want to use CSS and instead you want to use something called as Sass? That is also pretty easy to do. You just need to modify the name of the file to use one of the Sass extensions like SCSS. And you also need to install the Sass package as a dev dependency. So I can do pnpm add Sass, and then I can pass capital D to install this package as a dev dependency. If you're using npm, make sure you do npm install sass-d. This is going to install Sass. And just by doing this, we should be able to write the Sass inside of this file, and it should work as expected. Yeah, we also need to modify the import statement. My bad. So in the page.tsx file, I'll do SCSS. Save it, and we can see that our styles are working. My favorite way of styling web applications is using Tailwind CSS, and it is actually a utility for CSS library. What this really means in very simple terms is that for each CSS property, you get a class that you can apply to any element. This makes the process of styling your application really fast. But most importantly, you get a pre-built design system if you use something like Tailwind CSS. So even if you are not a designer, just by using Tailwind CSS in your projects are going to look much better. So let's set up Tailwind CSS step by step in our project. First, I'll replace the content of the home page with some simple JSX markup, as you can see over here. We'll open the terminal, and then we need to install some dependencies. So I'll do pnpm add. If you're using npm, make sure you do npm install. We need to install Tailwind CSS, Post CSS, Auto Prefixer, and make sure we install all of these dependencies as a dev dependency. Then we need to configure Tailwind CSS in our project. So I'll execute this command pnpm dlx Tailwind CSS init, and then I'm also going to pass -p so that it also creates a post CSS configuration for me. If you're using npm, the command for you would be npx tailwind css init -p. After executing this command, we should have two files, postcss.config.js and then tailwind.config.js. In this tailwind.config.js, within this content property, we can tell Next.js this is where we'll be writing our JSX and CSS classes. For Next.js project, we can use something like this. And what this means is that my components or pages will be present inside of this app directory or pages directory or this components folder. And if you're using src folder, then you can also do something like this. Since I'm not using the src folder, I will remove this line. I'm also going to remove this pages because I know the only code that I'll be writing ever is always going to be inside either in this app folder and the components folder that we'll create in the future. So by adding these two locations to this content property, we are just telling Tailwind CSS to watch for changes in all of these files. And whenever you detect any change related to CSS class names, you just take that CSS class names and its styles and inject it to the page so that we can see the changes in real time. Then in the globals.css file, we just need to add 3 directives from Tailwind. This is going to import the necessary styles like base, components, and utilities. Just by doing this, we should be able to use Tailwind CSS in our application. So I'll go to this page.tsx file, which is actually the home page, and I'm going to apply Tailwind styles like this, as you can see over here. If we take a look at this main component, we're saying that the display of this element should be flex, the items should be center, justify center. So item center and justify centers are properties related to flexbox. And if you hover over them, you can actually see the underhood CSS properties that are being used within these classes. If you're not getting these suggestions, make sure you install the Tailwind CSS extension in your VS Code. So as you can see, the styles are being applied perfectly and our UI is looking really good. So we have looked at 2 ways of styling your Next.js applications. Now a very common use case for styling is when you need to style some of the elements in your page conditionally. For this specific scenario, you can use a package from NPM called CLSX. It's a very handy utility package that you can use to toggle the class names within your elements. I will open the terminal and then I will install this CLSX package. If you're using NPM, make sure you do NPM install CLSX. And then I can import CLX from CLSX. Now let's consider this for example. Let's say that we have a variable called is subscribed. Now this is obviously contains a Boolean value. And right now is subscribed is set to true. So based on this condition, we can do something like this. So here's what we are doing here. Notice the syntax basically. When we call CLSX, this is going to accept 2 arguments. The first argument is the CSS string, well, the class string that you want to be applied in all of the cases, right? So for example, text SM and font semi-bold, this will be present in all of the cases. In the second argument, you provide your conditional classes. And here what I'm saying is that if is subscribed is set to true, inject this class. If this is not true, inject this class. So let's see this in action. I'll go here. I'll refresh the page once. Right now you can see this is an indigo color. Let's go to is subscribed and set it to false and see what happens. You saw that? Right now this is using a different color. So this is how you can use CLX NPM module to toggle the class names in your components or UI very easily. Let's see how you can use custom fonts within your Next.js application in a way such that it does not affect the performance of your application. Now for using a custom font, we first need to download a custom font. So right now I'm in the Google Fonts directory and I'm going to be downloading a font called Laundrina Sketch from here. I'm going to click on this, then click on Get Font and then click on Download All. This is going to download the zipped folder. And when I click on this, this is going to unzip that folder. So we can see that it contains an txt file and then ttf file. We are only interested in this ttf file, Laundrina sketch regular.ttf, right? Now I'm going to move this file to the fonts directory that is present inside of the app directory. So let me copy this. So as you can see, I have moved my Laundrina sketch regular.ttf file inside of the fonts directory, right? This already contains 2 fonts that we are not using. So let's delete these. Okay. Now we need to go to layout.tsx file. And in this layout.tsx file, we first need to import the local font function from next font local. And let me remove this boilerplate code for now. After importing this local font function, we need to call this local font, and this expects you to pass an object. This object contains a few important properties. First of all, it contains an src property. In this src property, you specify the location of your font file. So I can simply say that the location of my font file is this. Okay. The second really important property is this variable property, through which I can actually create a variable that is going to point itself to this font file. So let's call this my special font for now. Now let's store the result of calling this local font to a variable. Let's call this my font. And now what we need to do is we need to apply a class name to the body element. So we can take this my font variable, and there should be a variable property present inside of this font. This is going to apply a class name to this body tag. So with this, what I am doing is I am applying this font to my entire web page, entire body, right? If we take a look at the web page right now, it doesn't seem like that this is actually working. And the reason for that is because we still need to do one particular thing. Inside of this globals.css file, I'm going to select this body tag, and then I'm going to set the font family of this, and I'm going to set the font family to this variable called my special font. So when I do something like this, you'll notice that our font is successfully being loaded. Now, if you have never used CSS variable, let me explain how this is working. Inside of the layout.tsx file, when we are adding this class to the body tag, what this is doing is it sets up a CSS variable in the document, in the page, in the web browser. This CSS variable points to our font file. And then in the globals.css file, we are specifying that the font family of the entire body should be whatever this variable holds. Now we know how you can use any custom fonts within your application. Since Google fonts are so popular, Next.js gives you this ability of using any Google fonts directly. For example, if I want to use the inter font, I can directly import inter font like this. Let me get rid of the code that is associated with this local font. So I'll remove this line. I will remove this piece of code also. And then in the class name, let's remove this also. Yeah, so I can simply import this inter font like this. Then I can call the inter font, pass an object to this, and then pass some of the important properties. Weight defines what weight do you need for this particular font, 400 or 700 or 900, 100. If I do not specify this, all the font weights will be included. Display swap means that the browser will use a fallback font immediately to display the text, and as soon as the custom font loads, browser will swap out the fallback font. Since our app is going to be in English language, we are setting the subset to the Latin subset. Now, Latin subset, if you do not know, is a subset of a larger character set that contains all the characters which is required to show English language properly. And then in the body tag, I'm going to say class name is equal to font.classname. And when we are doing this, we can get rid of that CSS variable that we have applied to the body. And now in the browser, you can see that the inter font is being applied here. Perfect. So at this point, we now know how do you style your Next.js applications, how do you efficiently load custom fonts. Let's talk about data fetching now. In Next.js, we have two kinds of component, server component and client component. Server components are the default components in Next.js. And depending upon your use case, you can use a combination of both of these server and client components to create your Next.js application. In very simple terms, client components are rendered on the client side. And in the context of Next.js, client simply means browser. Server components gets rendered on the server. Here's how Next.js processes these components. For each type of component, Next.js creates a module graph. The server module graph contains all the server components, and the client module graph contains all the client components. After server component gets rendered, a special data format called React Server Component Payload gets sent to the client. Now this payload contains two important information. First, it contains the rendered results of server components. And the second thing that it contains is, it contains placeholders for where the client components should be rendered. React uses this payload to reconcile the server rendered content with the client side React tree. And then React hydrates the page to make it interactive. Now, if you do not know about reconciliation, reconciliation is simply the process through which React compares the new virtual DOM with the previous one so that it can efficiently update what is necessary. And hydration, on the other hand, is this process where React attaches event listeners to the components to make them interactive. Now, the important question at this point is, how do you decide if you should use client component or server component? To put this simply, if you need to make some part of your UI interactive, or you want to use hooks like use state or use effect, you will have to use client components, as these features are only available in the browser. You can use server components if you want to keep large dependencies on the server, and if you want to access the sensitive information, probably something like which involves your API keys or something, and or if you want to access the backend resources directly. For all of these scenario, you can use server component. So here is a little table from Next.js documentation that tells you when should you use which component. For example, what Next.js recommends is if you want to fetch data, make sure you use server component. Now it's not like you cannot fetch data on the client component. You can. It's just that Next.js recommends you to fetch the data on the server component so that it can optimize your application for the best possible performance. Similarly, if you want to access backend resources, if you want to keep sensitive information on the server, if you want to keep large dependencies on the server, for all of these scenarios, you can use server component. And for other things such as interactivity, state and lifecycle effects like these, if you want to use all of these, you can use client components for that. Now at this point, we already know this one thing, that the default component in Next.js is server component. That means this home page that we have over here is also a server component by default. If I want to convert this component to a client component, I just need to add this special directive at the top of the file called use client. And just by adding this directive at the top of the file, this component becomes a client component. Now, similar to this directive, we also have this another directive called use server. Do not make the mistake of thinking that just because use client makes a component client component, use server will make it a server component. This is actually wrong. Use server is actually another directive that we use to create a server action. We will learn about server action later in this video. For the time being, just understand this, that use client and use server has nothing to do with each other. If you want to convert your client component to a server component, you simply remove this use client directive from the top of the file. Alright, the process of data fetching for both client and server components are a little bit different. So let's take a look at these one by one. First of all, let's take a look at the client-side data fetching. I'm going to convert this to a client component by adding this directive at the top of the file. And then I'm going to remove everything that is present in this file and replace this with some simple content, as you can see over here. So right now we just have this main element. Inside this main element, we have this div. This div contains a heading that says quotes. And then we have this UL, which contains a list item, and then list item contains two paragraphs. In the first one, we'll be rendering quote, and the second one will be rendering the author. And we can see the UI in the browser. Perfect. Now, if you want to fetch data on the client side, you can use an use effect and fetch data within that use effect and then render whatever gets returned in the UI. However, according to Next.js, this is not the recommended way to fetch data on the client side. And what Next.js recommends is you should use libraries like SWR or React Query to fetch data on the client side. Now, these libraries makes data fetching way easier, and they handle caching, refetching, updating the user interface automatically whenever the data changes. And essentially, they remove a lot of boilerplate code that you would write yourself if you want to implement that kind of functionality. For the sake of this video, I'm going to be using SWR for client-side data fetching. Okay, I will open the terminal, and the first thing that I'll do is I'll install the SWR library. So by the way, SWR is actually a hook that is created by the team behind Next.js. And I'm going to install this by doing npm add SWR. If you're using npm, do npm install SWR. Okay. Now the first thing that we need to do is we need to import SWR from SWR. And since this is a hook, let's call this use SWR, right? Second step is to create a fetcher function. Now the thing about SWR is it gives you a lot of flexibility in terms of how do you actually want to fetch the data. So if you really think about it, SWR is not actually fetching the data. It's just that it is managing the result of that data and deciding probably when it should fetch the data. So it is not something that is actually fetching the data. And what I mean by that is you can use libraries like Axios or the native fetch API to make a request to the API endpoint and then give this fetch call to the SWR to manage it properly. Now the data that I'm going to be fetching from is this dummy JSON API, which is called dummyjson.com. Now I'm going to make a request to this API to get a list of codes. And this is always going to return a JSON response. So I can actually create my fetcher function like this. This fetcher function is going to accept this URL, which is going to be of type string. And then we are making a get request to this URL. If the response is successful, we're returning the JSON response from here, right? And when we call use SWR, it expects you to pass two arguments. In the first argument, we need to pass the URL from which we want to fetch the data. And in the second argument, we need to provide the fetcher function that we have created. Now, when we call this use SWR, this is going to return some of the useful things that we can extract. For example, this is going to return the data. This is also going to return the error if there's any. And then this is also going to give me this is loading state, right? So if you really think about it, these are the only things that really make sense when you are actually fetching the data. So either you'll get the data or you'll get the error, and then you need some sort of state which will tell you I'm actually making a request, right? And then when we get this data error is loading, we can actually check if we have this error. We can render this fail to load codes, please try again later. If we are loading, we are going to show them this loader. Otherwise, we are going to show them this UL, which is going to render the codes that we get from that API response. And this is complaining to me about TypeScript. So let's ignore this for now. Now, if we take a look at our application in the browser and refresh the page, you'll see we are first seeing the loader, and then after that, the code appears. To fix these TypeScript related issues, I can actually see the kind of structures that we're getting from this data. So let's actually log this. I'm going to log what we're getting from this. And now if I come here and inspect this, go to console, and we can see the data. That data is an object that contains few important properties: limit, quotes, skip, and total. And quotes is going to be an array that contains our array, right? Based on this, we can create a type. So for example, what I can do, I can create a folder called types. Inside of this types, I can create a file called code.ts, and then I can export two interfaces such as code and codes response. I can then import these interfaces like codes response and code. And then first of all, in the fetcher function, I can specify that this is going to return a promise to me, which will eventually going to resolve itself with the codes response like this. Okay. And just by doing that, TypeScript automatically figured out the structure of all the data. We are also not getting the error in this code. Okay. So we can actually get rid of this. Perfect. So let me recap this again. First, we converted this to a client component by adding this directive at the top of the file. Then we imported SWR. Then we created the fetcher function. And we know for a fact that our API is going to return the response in the JSON format. That is why we are returning the JSON from here. Then inside of this function, we are calling use SWR. And when we are calling use SWR, we need to provide two arguments. In the first argument, we are specifying from which endpoint I should request the data. And in the second argument, I am providing the fetcher function. When I call this use SWR, this gives three important things to me: data, error, and is loading. Now, based on these things, first of all, I'm checking if we have any error, render this paragraph. If we are loading, show them this loader. But if we are not loading, that means we have the data. And in here, we are actually rendering the codes that we get from the response. All right. So this was about client-side data fetching. Let's see how we can fetch the same data on the server side. First of all, I'm going to remove this use client directive. I'm also going to remove this use SWR, codes response also, and this fetcher function also. And then I'm also going to remove the code associated with SWR. All right. So we have something like this at this point. Right now, this is a server component, and we should be getting error at this point because we do not have errors. We do not have is loading all of these variables. Now, in order to fetch the data, I'm going to actually create a server action. Now server actions, if you do not know, lets you execute some of the code directly on the server, and it can be used as a replacement for route handlers also. We are going to be learning about route handlers a little bit later in this video. And there it would make a lot of sense how server actions is different from route handlers and how it can save you a lot of time. But for the time being, I'm going to create a new folder inside of this app directory. Let's call this actions folder. Again, the name of this folder can be anything. Inside of this actions folder, I'm going to create a file called code.ts. Now, the first thing that I'm going to do in this file is add this directive called use server. As soon as I add this directive to the top of the file, this file becomes a server action file. So that means whatever function I export out of this file will become a server action. So I can actually create this getCodes function and export it out of this file. This is going to be an async function. Now this is going to return a promise that will eventually resolve itself with this particular response, getCodes result. We're going to create this type in a little bit. And here's what we're doing here. First of all, we are making a fetch request to the same API. If the response is not okay, we are throwing an error. If the response is fine, we're getting the JSON response. And then we are actually returning this object. This object contains two important things, data and error. So in this case, since we got the data, we are actually sending the data and we are setting error to null. And it will make sense to you like why we are sending both data and error and why not just data. And similarly in error, we are returning this object in which data is null and we are sending this error message. So we know for a fact that if error is an instance of error, get the error message. Otherwise, send a generic message called something went wrong. All right. So now we can import the types from the code type that we have created. So we already have this codes response. We just need to add this getCodes result. So I can go to the code types and then in this file, I can just add this interface, which is actually going to be an object. And this object is just going to contain two things. Data. This data can either be a codes response or null, and then error. So this error message could be a string or null. All right. So we have created our server action now. In the home page, I can actually import this function called getCodes, and I'm just going to call this. And since this is an async function, let's convert our home function to async function also. When we're calling this, this is going to return a promise. So we need to await this also. And then we need to destructure a few things, get the data and error, because we are always returning these things whenever we are calling getCodes. Now we do not need this loading state because the rendering for this will be happening on the server side. So by the time this page reaches in the browser, it will contain the entire HTML, including the codes. So we can get rid of that loading. Now, if we take a look at if this is working or not, I'm going to refresh this and you can see this is actually working, right? So this is how you fetch data on the server side. Now, one really important thing about this server action. In this example, it is actually not necessary to create a server action. For example, if I just remove this directive from the top of the file, then this just becomes a normal TypeScript file. And if I show you right now, this is actually working. But consider this scenario for a second. Let's say in order to get the data from this dummy JSON API, you also need to provide your API key. And if you remove the use server directive from the top of the file, this just becomes a simple JavaScript file. And there is a possibility that this file can become part of the client bundle. So in those scenarios, you're going to leak out the API key to the client, which is not a good thing. So when you use server directive at the top of the file, Next almost guarantees that it is always going to be executed on the server side. However, for some reason, if you still do not want to use server actions and you want this code to not become part of the client bundle, there is also another option that you can use. You can actually install a package called server only. And then you can do something like this, import server only. So if you do something like this, and if there is any possibility of this file becoming a part of the client bundle, Next.js will throw you an error at the build time only. Now you know how do you fetch data both on the server side and client side. Now one important thing, the stable version of Next.js 15 has been released as I am making this video. So moving forward, we'll be learning things from the context of Next.js 15 only. The good thing is, all the things we have learned so far is equally valid for Next.js 15. So here's the plan moving forward. I'm going to follow the usual plan of covering all the core concepts in Next.js. If there is any new concept introduced in Next.js 15 which is stable, I'm going to cover that also in this video. Perfect. Let's upgrade our Next.js project from version 14 to 15. With this version, they have introduced a code mod CLI that makes the process of upgrading your project very easy. And I'm gonna be doing that only. Now you could think of code mods as little scripts that transform your code from one version to another. And Next.js team always releases these code mods whenever a new version of Next.js comes. This is the first time they have released a CLI tool for their code mods. And we are gonna be using the CLI tool only. This is going to make the process of upgrading your project very, very easy. So right now we can see that the React version that we are using is the version 18 and the Next.js version is 14.2.15. Let's upgrade this. So I will open the terminal and in this I'm going to execute this command pnpm-dlx, then next code mod, and since this is very new we'll have to use the canary version, and then we need to say upgrade to the latest version. Now when I execute this command, this is going to ask me a few questions. Now this is asking me whether do you want to enable Turbo Pack. Now Turbo Pack, if you do not know, is actually a replacement for Webpack, right? And it is supposed to be very, very fast as compared to Webpack. I have used this to be honest, and even though they claim that this has been stable now, this still does not support a lot of things that Webpack supports out of the box. So I'm not going to use Turbo Pack, at least at the time of making this video. Then this is showing me all of the code mods that are available. So we can choose all of these and then I'll just hit enter. And since our project will now be upgraded to React version 19 release candidate, this is asking me whether do you want to upgrade your existing code from React 18 to React 19. So I'm going to choose yes for this. For types also I'm going to upgrade. Now this is asking is your app deployed to Vercel? It is not, so we can say no. Okay, so it looks like the project has been upgraded to Next.js version 15. And we can see that in the package.json file. So we can see that the next version that we have is 15.0.0 and the React version is 19.0.0. RC stands for release candidate. Okay. All right. Let's start the development server, and it updated my TypeScript configuration file also. Let's go to localhost 3000 and see if this is actually working or not. Okay. So it looks like this is working. And in this version, they have added this indicator which tells you if this route is static or dynamic. We are going to learn all about these things later in the video. Now Next.js has something called file-based routing system. And what this means is if I want to create a route called, let's say, about, I can simply create a folder called about, and inside of this about folder, I can create a file called page.tsx. If you're using JavaScript, you'll do page.jsx. And since I'm using TypeScript, that is why I'm doing page.tsx. Okay. Now this is just going to be a default function. Let's call this about, and this is going to return some JSX from this. So let's just say about page for now. Okay. Just by doing that, we can go to the browser and we can access this about page like this, as you can see over here. So that's why it is called file-based routing system. Because if you want to create a route, you simply create a folder that maps to that particular route. And then this special file page.tsx makes any route publicly accessible. Okay. Now what if I want to create a nested route? For example, what if I want to create something like this? So after this about, I want to go to this page about me or something. So right now this is taking you to 404 page. This is called a nested route, and the way you create a nested route is really simple. So we need to create another folder inside of this about directory, about folder. So I'm going to create this folder and I'm going to name this me. And within this folder, I'm again going to create a file called page.tsx, right? This is again going to be a component. Let's say about me, and I can return some JSX from here also. So just by doing this, we should be able to access that page in the browser about me. So this is how you can create a nested route. Now let's say you want to create a really deeply nested route, something like blog, and then let's say year goes 2023, and then we can pass the month. Now, if you want to do something like this, you can definitely create your folder structure like this. For example, I can create a blog folder. Inside of this blog, I'm going to create another folder called 2023, let's say. And within this folder, I'm going to create another folder, and let's pass this the month. Okay. Now inside of this folder, I can create a file called page.tsx. And then this page.tsx file is going to just return some simple tsx from this file. Let's call this blog post, return. Okay, so now we can see this in the browser. Now you could imagine that similar to this could go even deeper than that. And so in those scenarios, it does not really make sense to just keep on creating nested folders like this. So for these kind of scenarios, what we can do, we can essentially create a catch-all route. And what we can do with catch-all route is, so after this blog segment, whatever appears, we are just going to load a simple page for that. Let me show you. So first of all, I'm going to delete this month folder and I'm going to rename this year folder to something like in a square bracket, then triple dot, and then let's call this query. Okay. The name of this can be anything. It is not important. Now within this folder, I'm going to create a file called page.tsx. Let's call this blog post. And now this is just going to return this paragraph called blog post. Okay. So with this, what should happen is if I try to access any route and no matter how deep it is always going to load this particular page. Now here comes the interesting thing. What can we do with this information? Now, first of all, you could imagine that this query is going to contain the entire route segment that appears after the blog. And we can access that route segment by doing something like this. So we can get the params, and this params is actually going to be an object which is going to contain our query. And this query is going to be an array for now. And this array is going to contain a list of items in the format of string, right? More like this. And we can get the query from the params by doing something like this. Now the await is only required if you're using Next.js version 15. So with Next.js version 15, what they have done is they have actually made this breaking change in which all of these operations that rely on request specific data, such as headers, cookies, params, or search params, these are all now converted to an asynchronous functions. So that is why they're always going to return a promise, and we need to await that promise. We need to wait for the response. Then we can get the query. And if I just try to log the query here, and since we are using await in this one, so we need to convert this to an async function. And now you can see that we are actually getting this query information 2023. So you could imagine based on this information, you can fetch the necessary data from your server, from your database, and then render the result of that request in this page, which will be sent back to the client. And one quick thing related to TypeScript, even though we have just upgraded the project to Next.js 15, we can see in the VS Code, this is telling us that await has no effect on the type of this expression, which is actually false, because if I remove this await and just try to directly access the query from this params, this is going to blow up the application. As you can see, error in route this, a param property was accessed directly with params.query. Param should be awaited before accessing its properties. So that is why we need to await these params in order to access these things properly. Okay, so we know at this point that page is a special file that makes any route publicly accessible inside of the app directory. Now we have a lot of other special files in Next.js also, such as layout, template, loading, error, and other. Let's understand these one by one. Layout allows you to define the structure of your application and also lets you share the common elements across different pages. For example, we have this layout file inside of this app directory, as we can see. Whatever we include in this file is going to be shared with the current segment and all of its children. Now, if you take a look at the structure of a URL, you could say that this localhost colon 3000 will be the host. And then after that, anything that is present that is separated with a forward slash is going to be a route segment. For example, this about is a route segment. This me is a route segment. And we can also say at the same time that this route segment is a child of this about route segment. And since we have created a layout file directly inside of the app directory, whatever we include in this file is going to be shared with every page in our application. Okay, but what if you want to share a few things only with certain pages? So let's say I create a folder called page 1, and inside of this folder, I'm going to create a file called page.tsx. Now this is just going to return some simple JSX that says page 1. Okay, so similar to the page 1, I've also created this page 2. This just says page 2. And since these pages, page 1 and page 2, are directly part of this app directory, we should be able to access these pages by going to this particular route. As you can see, this is page 1, and then I can also go to page 2. This is page 2. Now imagine this scenario. Just for these pages, page 1 and page 2, you want a different kind of layout. Now what we can do, we can actually create a route group here. And let's call this shared. And the way you create a route group is you always open and close parenthesis, and then you write anything inside of this parenthesis. So this is how we create a route group. Now the good thing about route groups is that they do not map to any particular route segment. They're just here to organize your code in a better way. So I can move these files, page 1 and page 2, inside of this shared folder, as you can see. And since these route groups do not map to any route segment, I should still be able to access my pages like this. Notice I'm not doing something like this. So it's not like I'm doing this shared and then trying to access this page too. If I try to do something like this, it is going to take me to a 404 page. And since route groups do not map to any particular route segment, that is why we do not need these over here. We can simply access the page 2 like this only. But since we have grouped these pages like this, I can create a layout file directly inside of this shared folder like this, layout.tsx. And then this is just going to render the children. But then just let's say I'm also adding this an h1 to this layout, which has this shared layout, right? So with this, what happens is whatever I include in this particular layout file, it is going to be shared with the current segment. For example, this page 1 and page 2, and any other nested pages that we have present inside of both of these two folders. Let me show you. Okay, so this is one of those things that I'm continuously getting after upgrading my project from Next.js 14 to 15. So if you encounter something like this and your code is actually correct, what you can do, you just need to restart the development server. And this should fix your problem, as you can see. So you can see when I'm trying to access the page 2, I'm seeing this shared layout, which is coming from the layout, right? And if I go to page 1 also, this is coming, shared layout is also here. But if I try to access any other page, let's say if I try to access just the home page, you won't see that text over here. Now, similar to the layout file, template files also define the structure of your application, and they also allows you to share the common elements between different pages. The difference between a layout file and a template file is that layouts provide a consistent structure that does not re-render when navigating between pages that share the same layout. What I mean by that is only the page content gets changed, but the layout remains the same. But in case of templates, entire template gets re-rendered whenever a page that uses the template is loaded or navigated to. So that means even shared elements in a template will re-render with each navigation, unlike layouts. And since template file gets re-rendered every time whenever a page gets loaded, it is very useful for those cases when you want to implement a page views track or something. Let me show you. I'm going to create a new folder called components. And within this folder, I'm going to just create a component called page. Let's call this views tracker. And here's what we're doing in this component. First of all, this is a client component. We are actually creating a state variable page views. And whenever this component gets loaded, we are getting the page views from the local storage and incrementing this by 1. And then we are storing the updated value to the local storage again. And we're also rendering the page views over here, as you can see. Now what I can do, I can add this component to my layout file and see if this is actually working or not. So let's go to the layout file, and I'm going to just import this component like this views tracker over here. If I just come here, you can see that the page views is 1. But if I refresh this page views is 2 now, page views is 3 now, page views is 4 now, right? So this is happening because we are actually doing a hard navigation. We are doing a full page reload. But let's say if I add a link to this particular page, that is going to take me to another page via soft navigation. So for example, I go to this page.tsx, and within this main component, let's say we add a link or something. So now we have 2 links. First one takes us to page 1 and second one takes us to page 2. So if I just come over here and I click on this page 1, you'll see that the page views is still 6. If I go back from here, you can see the page views is still 6. So you see that this is not working as expected. Okay, so let me remove this views tracker from this layout file to a template file. So what I'm going to be doing is I'm just going to remove this, and inside of this app directory only, I'm going to create a file called template.tsx, and let's call this template. And again, this is just going to render the children. And now we can add views tracker over here. So now if I refresh the page, you can see this page views is working, but this was also working with layout based implementation. Let's see what happens when I click on these links to do a soft navigation. So if I click on this, you can see that this has been updated to 12. And the reason why this is incrementing by 2 is because we are in the development mode right now. Let me go back again. You can see that page views is 14 now. If I go to page 2, it is 16. And when I do a full page reload, you can see that this is also working. Okay, let's talk about loading file now. But before we do that, let me do some cleanup. So I'm going to delete this shared folder, going to delete this about folder also, and then I'm going to delete this blog and actions folder. So pretty much as if we are starting from scratch. Okay, I can also get rid of this fonts directory. I can get rid of this page.model.css file, and this template file also I can delete. Now I'm going to replace the content of the homepage with this simple hello world. Now loading file can be used to show a loading UI if one of your routes taking some time to load. So to understand this loading file, I have created this post folder inside of the app directory and then a page.tsx file. So you could imagine that this is a page that lists out all the posts that is available. Now here you could fetch post from database. Now when you fetch post from database, there is this possibility that it could take some time. I can add this line of statement that is going to simulate a delay. So you could imagine that we are making a fetch request to get the data, and then it is taking about 3 seconds of time to load the data, and then we'll send out this page to the front end, right? Now, if I try to access this page in the browser, you'll see that we are having this loading indicator, and after 3 seconds, we get the post content, as you can see over here. Now, this is not a very good user experience if you really think about it, because we're waiting for 3 seconds and then after that, the page is being loaded. So this is not a good user experience. What we can do about it, inside of this post folder only, I'm going to create a new file called loading.tsx, right? And you can add your loading UI in this one. Now, just by adding this loading file to this route segment, if any page in the current route segment or any children of this route segment take some time to load, we are going to show this loading UI. So now when I refresh the page, you'll see that we are first seeing this loading indicator, and then after that, the content appears. Now, similar to this loading file, we also have this error file. And the purpose of the error file is to capture any error that occurs in the current segment or any children route segments. And here's what I'm doing in this error file. First of all, this needs to be a client component. You cannot make this a server component. And here's the important thing. So in this error file, we can get the error and reset method. Now this error message is self-explanatory. This reset method can be used to re-render the route segment in which the error occurred. So you can provide a button. When a user clicks on this button, we're going to call this reset method, right? So if I come to page.tsx file and just throw any error, for example, if I just throw an error from this file, it is going to be captured by that error boundary. And you could see after this loading indicator, we are seeing the content from the error file. Something went wrong, try again. And when I click on this try again, it is again going to re-render that component. You can see 6 errors. Now the reason we are seeing this overlay, because Next.js is helping us out to pinpoint where the error is occurring. But the important thing to note at this point is we are seeing the content from this error file. Something went wrong, try again. Now this error file is only going to capture errors that occurs in this route segment and all the children route segments. If you want to capture all the errors that could occur in anywhere in your application, there is this other file called global error. And you need to create this file directly inside of the app directory. The name of this file is going to be global error.tsx. Now the content of this file is exactly like what we saw in the error file. This is a client component. We get the error and reset method, and then you can provide a button to reset the part from where the error occurred. The only difference is that we are returning the entire HTML from here. If you compare this with the normal error file that we have over here, you can see we are returning a normal div. But in case of global error, you have to return the entire HTML from here like this. So let's see if this is working or not. I'm going to remove this error file that we have created. And if we take a look at this page.tsx file that is present inside of this post folder, you can see that after 3 seconds, we are going to throw this error. And we have deleted the error file from here. So that means this error should be captured by this global error file now. Let's see if this is working or not. So I'll come here, I'll refresh this page. So we are not actually seeing the content of that file. And the reason for that is because we are right now in the development mode. So when you are in the development mode, Next.js is going to show you this overlay to help you out, like where are things going wrong. But if this is something that happens in your production server, user is going to see this UI. So route is a special file that lets you create custom API endpoints for your application. Let me show you. Inside of this app directory, I can create a folder called API. And within this folder, let's say I create a folder called posts. Now this post can contain a file called route.ts. Whenever you create a file called route.ts inside of the app directory, you are essentially creating a custom API endpoint. And in this route handler, I can set up a bunch of methods. For example, this get method. What this means, whenever I get a get request to this particular route, which is API/post, just send them this JSON response. So let's see this in the browser if this is actually working or not. I'll go to address bar, and in the address bar, I'm going to say API, and then I'm going to say posts. Now, when I do this, you'll notice that we are getting that JSON response from the server. And similar to this get method, you can create other HTTP methods also. Like when you receive a post request, you can send a response from here. When you receive a put request, when you receive a delete request, right? You get the idea. All of these methods that you are seeing in the screen are supported in case of route handlers. Okay, now let's talk about some of the advanced routing functionalities that are available in Next.js. And I am essentially talking about parallel routes and intercepting routes. First of all, I'm going to delete this global error file. And then I'm also going to delete this API folder. All right. Now parallel routes allows you to render multiple pages within the same route segment. For example, I can create a dashboard page or something, as you can see. In this dashboard page, I can render two different pages, teams page on the left hand and then projects page on the right hand. Now, when you see something like this, you may think that you can create this kind of layout just by using normal simple components. Then why do you need parallel routes in this case? First of all, you can definitely do that. And in fact, if your application is simple, it is not complex, you should definitely do something like this with the components based approach only. Now, parallel routes exist for those scenarios in which your application is a little bit complex. And some of the benefits that it can provide you instead of just using simple components are like this. Okay, so as you can see over here that these two sections are full-blown pages in Next.js. And since these sections of the page are not normal components, but actually full-blown pages, Next.js can load these pages independent of each other. It can also do code splitting, as you can see over here, because in Next.js, if you do not know, code splitting happens automatically based on the route segments, right? So now these two would be a different page, and that is why Next.js is going to split their code to improve their performance. And since both of these sections are now actually full-blown pages, you also get access to all the special files like loading and error. You can directly use those files within these to show their loading and error states. You also get something called as URL-based state management. Now this will make sense a little bit later in the video. And finally, you also get a little bit better code organization if your project is very complex. Okay, let's see how we can implement parallel routes. Now the first thing that I'm going to be doing is inside of this dashboard file, I'm going to create a page.tsx file. Now this dashboard file is not going to return anything. I am just creating this file so that I can access the dashboard route segment in the browser. Okay. Now within this dashboard, I'm going to create two slots. And you could imagine that both of these sections can be called as individual slots. So this is one slot and this is another slot. And the way you create slots in parallel routes is by creating a folder. The name of this folder should start with an @ symbol, and then I can name my slot. So let's call this team. Okay. Within this slot, I'm going to create a file called page.tsx, and this is just going to be the team page. So let's just say, let's return a heading or something. Let's call this team slot. Now, similar to this slot, I'm going to create another slot within this dashboard folder only. Let's call this project. This would also contain a page.tsx file, and I'm just going to add a heading which says project slot. All right. So now we have created these two slots. Since we need to create a layout like this, we are also going to be needing a layout file. So inside of this dashboard folder only, I'm going to create the special file layout.tsx. Okay. Let's call this a dashboard layout. And as you know, like any layout, we render children over here. Now children, if you do not know, is also a slot. It's just called an implicit slot because we have not created this slot. This has been given to us by Next.js themselves. And similar to this children, we can access our other slots that we have created, like team and project. Both this team and project are going to be type of a React node, and then we can render these over here. So I can add a heading called dashboard layout, and then I can render the team and project slot over here. Now in this specific scenario, I do not really need this children slot, so I can get rid of this. And we just have a layout like this. Now I've just added a little bit style so that these renders left and right. Okay. At this point, if I try to access this dashboard page, you'll see that we are actually seeing our dashboard layout, team slot, and project slot. And also let me add a little bit of padding to this layout so that we can see the content a bit easily. So inside of this div, I can simply add a padding or something. All right. Now, one of the things that you have to know regarding these slots is that these slots do not map to any route segment. For example, you cannot do something like this in the browser. So you cannot do something like dashboard /@team. If you try to do something like this, it will take you to a 404 page because these slots do not map to any route segment. Okay. Let's say this project slot is going to take some amount of time for you to load. So for that, I can make this an async function. I can add an await, which is going to wait for 3 seconds before returning this JSX from here. So now if I just come here and refresh this page, you'll see that we are actually waiting for 3 seconds before actually rendering the content over here. It will make a little bit sense if I show this in the incognito tab. So if I just come here, you'll see for 3 seconds we are not loading anything, right? The usual stuff. So to fix this, what we can do inside of this slot only, I can create a loading.tsx file. And now this is just going to say project loading. Now it is going to render very, very fast. So as you can see, the project is loading, and then after that, the project slot appears. Let me show you again, as you can see over here. So similar to this loading file, you can use any other special file that we have talked about in this video. So this is how you can create parallel routes in your Next.js project. Now, one of the really good things with these slots is that they can show different content based on the URL structure. Let me show you what I'm talking about. Let's say, well, first of all, I'm going to delete this loading file. And I'm also going to delete this promise. Now inside of this project slot, I'm going to create a new folder called settings, right? Within this settings, I'm going to create a page.tsx file. Okay. Now this is going to be actually a settings. So it's not actually settings slots. It's called settings page. Okay. Let me explain one more time what I'm doing here. Inside of this project slot, I have created this settings folder. This settings folder contains a page.tsx file. Now this file just returns a symbol h1 that says settings page. And then in this team slot, within this page, I'm going to add a link. So within this team slot, I have added this link that says, let's say, go to settings. When I click on this button, it is going to take me to this particular URL. Now notice the URL. I have set dashboard settings, right? And the reason why I have set dashboard settings is because these slots do not map to a route segment. So the way you access this settings page is by imagining that something like this does not exist. Okay, let's see what happens when I click on this button, go to settings page. So when I click on this, the first thing that you'll notice is right now the URL has been changed to dashboard settings. And in this side, we are seeing the content of the settings page, but the content in the team slot have not changed. And the reason for that is because we have done something called as soft navigation. So soft navigation essentially refers to client-side navigation. So when we're trying to access this dashboard settings, the project slots contains the settings page. That is why the settings page is showing over here. but team slot does not have any settings page. That is why the content for the team slot does not change. Now this would be a different story if you do a full page reload. For example, right now the address is dashboard settings. If I refresh this, it is going to take me to a 404 page. So what is going on? Well, the reason for this is because when you're doing a full page refresh, you're actually doing a hard navigation and you're trying to load this particular route, dashboard settings, right? Now inside of the project slot, settings page does exist, but inside of the team slot, there is no settings page. So Next.js has no way of knowing what should it render inside of the team slot. And that is why it takes you to this 404 page by throwing an error. Now there are two ways to fix this problem. You can either add a settings page inside of the team slot, or you can add a default file to this team slot. For example, default.tsx. So I'm just going to call this team default. Now what this default file allows Next.js to do, it is your way of saying Next.js that if someone is trying to access a route that does not exist within this slot, simply load the content from this default file. So now even if you do a full page refresh, it is going to show you the default content for the team slot and the settings page content for the project slot. Let's try going back to the dashboard page again one more time. So now when we are in the dashboard page, we can see that we are rendering the team slot that contains this go to settings page button, and we also rendering this project slot, right? But when I click on this button to perform a soft navigation, the content for the project slot changes because it contains the settings page. The content for the team slot does not change because it does not contain any settings page. Yes, we have added a default file to the team slot, but that gets only kick in when you do a full page refresh. So if I do a full page refresh, it is going to load the default file for the team slot and keep on showing the settings page content for the project slot. So depending upon if you're doing a soft navigation or hard navigation, you are going to show different content based on the default file and if there's any route present inside of the slot or not. The interesting thing to note at this point is for all of these routes, dashboard, settings, we are just rendering the same layout every single time. We are just changing the content of the layout based on what the user is trying to access from here. So this is what I meant by URL dependent state management. I can simply take this URL and share this URL with anybody out there, and they'll be able to access this exact state of my application. Intercepting routes allows you to share a different kind of UX based on the context of the app and how user is navigating through the app. Let me give an example. So imagine you have this photo gallery page. Whenever a user clicks on any of these photos, it opens a model and show a detail of that photo. And when this model is opened, the URL in the address bar also gets updated. But when we do a full page reload over here, we take the user to a different page altogether, photo detail page. Let's see how we can build something like this. First of all, I'm going to delete all the code that is present inside of this dashboard folder. I'm going to create a gallery page first of all. This gallery folder is going to contain this page.tsx file. Within this app directory also, I'm going to create another folder called data, and let's add another file called photos.ts. Now we are just exporting this dummy photos array out of this file that contains different objects, and these object has this src property which contains the URL of the photos. Then inside of this gallery page, I'm just getting those dummy photos, looping through those photos and then rendering these images over here. So if I go to the browser and try to access this gallery page, we are getting an error that you cannot access images.pixels.com. So what we need to do is we need to add this images.pixels.com to the next configuration so that it allows loading of images from this domain. So I'll go to my next configuration file. Within this file, I'm just going to add images, and within this, I'm going to add these remote patterns, which is going to be an array. And then I can specify the host name of my image, something like this. I can save this, then I come to the browser and I refresh this page. And you can see the photo gallery is working. Now let's create a photo detail page that would open when we click on any of these photos. Right now it is taking us to 404 page because this particular URL does not exist. In this case, we need to create a dynamic route. So inside of this gallery, I'm going to create another folder. And since this is going to be dynamic, I'm opening and closing this with square brackets. I'm going to name this variable ID, and inside of this folder, going to create another file called page.tsx. So in this page, I'm just getting the ID from the params, as you can see over here. Based on the ID, I'm trying to find the correct photo from the dummy photos and then checking if the photo exists. If the photo does not exist, I'm showing them this UI that photo not found. Otherwise, I'm rendering this image with all of its details. So let's see if this is working or not. I'll come here. I will click on any of these images. And as you can see, this is working as expected. Now let's improve the user experience by intercepting the route of the photo detail page. So what is happening right now, when we are clicking on any of these photos, we are taking the user to this particular route. That means we need to intercept this route and show a model over here. We can achieve this with the combination of both parallel routes and intercepting routes. Now, the first thing that I'm going to be doing inside of this add directory, I'm going to create a slot called model. This model is going to contain a file called page.tsx. Now, by default, this model should not appear or should not render anything. So what we'll be doing is this model page, it should return null. Then in the layout file, we need to access this model, and then we need to add this model to the page so that it becomes part of the layout. Now within this slot, I'm going to create a folder, and the folder name is going to start with something like this: open and close parentheses. Within these parentheses, I'm going to just add a single dot. Then I'm going to say gallery, and within this folder, I'm going to create another folder. Let's call this ID, and within this ID, I'm going to create another file called page.tsx. Okay, let's talk about the convention a little bit. So you'll be using single dot when you need to match segments on the same level, double dot to match segments one level up, and then 4 dots like this to match segments 2 levels up. When you do 3 dots like this, you're essentially talking about starting from the root app directory. Now, since we want to intercept this gallery ID page, now this gallery folder exists on the same level on the route segment as this intercepted folder. That is why we are just adding this single dot. And by the way, we are not talking about the relative position with the reference from a file system view. We are talking from the reference of a route segment. Since model do not map to any particular route segment, that is why we have just added a single dot over here as if this model does not exist. But if this was a different story altogether, let's say if this was something else like, I don't know, maybe dashboard or something. So if this was dashboard or something, then to target this gallery folder, we would have to go one level up, because when we go one level up, then we'll go inside of this app directory. And then inside of this app directory, we have this gallery folder. So to go one level up, we'll need to add 2 dots over here like this. Okay. All right. Let me change this again. I'm going to make this model, and now I'm going to make this single dot only. So within this intercepted route, this page.tsx, my logic is pretty much the same. First of all, I'm getting the dummy photos, and then I'm checking the ID. Based on the ID, I'm trying to find the correct photo. If the photo does not exist, I'm returning null. Otherwise, I'm rendering this photo in a model or something. Okay, let's see if this is working or not. I'll refresh the page. I'll click on this, and it seems as if it is taking me to the detail page only. Let me restart the development server. Let's try this again. I'll come here, refresh the page. Okay, so this time we got 404 error. This should not happen. Let me refresh this again. Okay, so we are getting a 404 page. Okay, I think we probably need to delete the .next folder also. Let me restart the development server. Let's try refreshing this again. So I think this has something to do with this page.tsx file that is present inside of this model slot. Probably this should not be page.tsx. This should be default file, default.tsx. So if you have a default.tsx, now this is working. So now when I refresh the page, when I click on this, we are loading a model within this page only, and you'll see that the route gets updated also. But when I refresh this page, it is going to take me to a different page altogether. Let me show you again. I'll go to this page, go to the gallery. When I click on this, it is going to show that image with details in this page only. But when I refresh this page, it is going to take me to another page or something. Another thing that you would notice is when I click on this, it opens a model, the URL gets changed. And when I go back, like when I click on this, it takes me to the gallery page and it automatically closes that model. Right now, this page that I have created, which is a model, is actually a server component. If you want to provide a close button also, all of those things, you can add a little client component that will take you to the previous browser history. And that is automatically going to close the model for you. Now, there are 4 ways to do navigation in your Next.js application. But before we learn that, let me do some cleanup. So I'm going to delete this model folder, this data also, this gallery also, and then this post also. And I think from layout, I can also remove this slot that we have added, model. Okay, so there are essentially 4 ways to do navigation in your Next.js application. First, you already know, which is by using the Next.js link component. So I can import a link from next link, and then here I can specify to go to any page. For example, whenever someone clicks on this link, they will go to about page, right? We do not have any about page. So if I just simply create an about page like this, and if I go to the browser, refresh the page, when I click on this about, it takes me to the about page. The other 3 ways that I'm going to show you allow you to programmatically navigate your users from one part of your application to the other. Let me show you. Okay, so let's first see this in a client component. I'm going to add this use client directive at the top of the file, and then I'm going to remove this link component. Since this is a client component, this cannot be an async function. So I'm going to remove this also. In case of client components, you can use a hook called use router, and make sure you import this hook from next navigation, not from next router. Okay. All right. So we have imported this use router. Then we are going to call this use router to get the router instance. And then I can add a button or something. When someone clicks on this button, we are going to call this push method that is present inside of this router instance. And then it will take us to the about page. Let's see if this is working or not. I'll come here, go to home page, refresh the page for once. I'll click on this about, and you can see that right now I am in the about page. You can also redirect your users from within a server component. So I'm going to remove this use client directive from the top of the file. This now becomes a server component. I'm also going to remove this use router code, and then I can import redirect from next navigation. And now you could imagine this scenario that, let's say I have this variable is authenticated or something, and I'm checking if the user is not authenticated. I want to redirect the user to this login page. And since this is a server component, we cannot access this on click like this. So let's remove this line from here. Right now, the login page does not exist. So let's try to redirect the user to about page only. So you can see right now the user is not authenticated. So when I try to access the home page, it should redirect the user to the about page. Let's see if this is working or not. I'll come here. I'll try to access the home page, and you can see I have been redirected to the about page. Now you can also use this redirect function within your client components. In the documentation, you can see that a redirect can be called in client components during the rendering process, but not in event handlers. Usually what you should be doing is you should be using use router if you want to programmatically navigate or redirect the user from your client components to a different page. But during the rendering of your client components, you can also use this redirect function. All right. But the last way to redirect or navigate the user from one page to another is by using the native history API. And since now you're trying to access something that exists only in the browser, that means if you try to access this code, your component needs to be a client component. And then you can use these methods, which is present in window.history API, post state and replace state, to actually modify the browser history stack. This is not the recommended way of doing things in Next.js, as if you'll be using this, you may lose some of the benefits that we get from Next.js routing system. The only reason I told you that this exists so that you have this idea that something like this exists. All right, let's talk about rendering now. So we are gonna first talk about rendering related to server components. I'm going to remove this code related to redirect like this. So when we're talking about rendering related to server components, we need to understand static rendering and dynamic rendering. Static rendering is when the rendering for your route happens during the build process. So if you do not know, I can actually execute this command npm build. If you're using npm, you can do npm run build. This is going to create a production version of my application, and it is going to optimize your application for the production essentially. By default, Next.js tries to render everything during the build process. And that's why they say that static rendering is the default rendering in Next.js. So after the build process has been finished, as you can see, Next.js shows you this little report over here. And the interesting thing to look at is that this empty circle represents that a route has been rendered statically. So right now we can see that our home page has been rendered statically and about page has also been rendered statically. Okay. Now dynamic rendering is when rendering happens during the request time. That means whenever server gets a request to access any page, at that time only the server is going to render that page and then it is going to send that page to the client. And one of the ways you can tell Next.js to render any route segment dynamically is by exporting this route segment configuration option dynamic and setting its value to force dynamic. So what this tells Next.js is that do not render this route statically or during the build time. Whenever you get the request to access this home page, just render it during that time and then send it to the client. Let me show you. Now if I do npm build, you can see that now we have a different kind of symbol in case of our home page. And the meaning of this symbol basically means that this route is now dynamic, server rendered on demand, right? Now there are a lot of other dynamic APIs available. So if you use those dynamic APIs within your page, your component will automatically become a dynamically rendered component. For example, if you try to access cookies, if you try to access headers, if you try to access search params, these things. So when you're trying to access these things, you are essentially relying on a request time information. And when that is the case, Next.js cannot render your pages during build process because now your page has some information that Next.js can only get when an actual request comes. You can see the full list of dynamic API on the screen right now. If you try to access or use any of these things, your route will become dynamically automatically. Now, if a route or component takes some time to load, you can stream that route or UI component from server to client. And you have actually saw the streaming of route segments when we use the loading file. For example, let's say that this home page is an async function and this async function takes some amount of time to load, let's say 3 seconds. Inside of this app directory only, I can create a file called loading.tsx. This is just going to be a simple loading file. And now when I try to access this home page in the browser, as you can see, if I refresh this page, you'll see that we are first seeing this loading text and then after 3 seconds, the entire page appears. So this is called route streaming, right? Now, similar to this idea of route streaming, you can also stream your UI related components. Let me show you. I'm going to remove this promise line from here, and I'm also going to delete this loading file. Let's also delete this about folder. We do not really need this, okay? All right. Okay, so now we have this home page. So inside of this components folder, I'm going to create a new folder. Let's call this server component. And this is just going to be a simple server component. Again, this is going to be an async function. And this is also going to take 3 seconds to render or load properly. Now in the home page, I'm going to use this server component over here. So now when I try to access the page and I refresh this for 3 seconds, you are going to see this loading indicator. And then after that, the page appears. Okay, so I think this is not very clear with this. Let me load this in a new tab, okay? I'm going to open this in here. And then you can see for 3 seconds, we are not loading anything. And then after that, the content appears, right? Okay. So to improve the user experience in this scenario, what we can do, we can wrap this component, which is taking a lot of time to load, with a suspense boundary. So I can import suspense from React. And then this is going to wrap the server component, which is taking some time to load. So what this suspense is going to do, first of all, this is immediately going to show this loading div. And then after that, when this component is ready, it is going to replace this text with this component. Let's see. So I'm going to come here, refresh the page. You'll see that the loading is here. And then after that, the server component is shown. But the thing is, now our page loaded instantly, like very, very fast. Let's talk about rendering related to client components. The interesting thing is that even for client components, the initial rendering happens also on the server side. The reason Next.js does something like this is that when someone visits your site, they see at least some content right away without waiting for the full JavaScript to load. So here's how all of this happens. First of all, in Next.js, client components are rendered differently based on the type of request. So if you're doing a full page reload, essentially on your first widget, Next.js is going to render that page in one way, but on subsequent navigation, it is going to render that in a different way. So in case of full page load, which you can also call the first widget, Next.js first creates a static HTML preview of both server and client component on the server. So on the server, what happens is that React renders server components into a special data format called React Server Component Payload. And this payload contains references to client components. Next.js then uses this payload and client component JavaScript instructions to render HTML for that route on the server. And then on the client, this HTML is used to immediately show a fast, non-interactive initial preview of the route. Then React Server Components payload is used to reconcile the client and server component trees and update the DOM. Finally, the JavaScript instructions are used to hydrate client components and make them interactive. So this is the whole process that happens on a full page reload. But on subsequent navigation, the entire rendering for the client components happens on the client side, on the browser itself. Okay, let's talk about the composition patterns for using the client and server components. I'm going to remove all of this code for now. So now in the home page, we just have this hello world text. And then after that, I'm going to remove this views tracker also because we do not need this. Now in this server component, I'm going to remove this promise. And let's also remove this async keyword from here. Okay, so this is a server component. Let me create another component, which is going to be a client component. So as you can see, this is a client component, right? Now let's go to the home page. Right now, our home page is a server component. Let's convert this to a client component. Let's remove this async keyword from here. Okay, let's talk about the supported patterns. First of all, we can import client component within a client component. So this home page is a client component. Let's import this client component that we have created. Let me import this also. And if we take a look at this page in the browser, you can see that the client component is rendering over here. We can also import client component within a server component. So if I remove this use client directive from the top of the file, this home page becomes a server component in which we are importing a client component. So if I come here, refresh the page, you can see this is still working. We can also import server component within a server component like this. So if I come here, you can see that client component is working, server component is working. The last case becomes, can we import a server component in a client component? So I'm going to again make this home page a client component. The short answer is you cannot. You cannot import a server component in a client component. If you try doing this, this is still working. But why is that? Even though this is working, you are not understanding the bigger picture here. When you import a server component within a client component, this server component also becomes part of the client bundle, right? For example, if I add a console log to this server component that says server component, you will be able to see this console log in the browser, as you can see, because now that server component has become part of the client bundle. This is not what you want. Why, you may ask? Well, because, there are multiple reasons for that. First of all, since the server component has now become part of the client bundle, that means you're sending more JavaScript to the client side. Second thing is, in server components, you may be doing some things that you do not want to ever come out on the client side. Maybe it has something to do with your API keys or something. So if this becomes a part of your client bundle, you are going to have issues. For example, if I add a code like this to my server component, And what this is doing is this is going to create an example.txt file in the root of my folder with this content. So now if I do something like this, you directly import this server component inside of your client component, and Next.js will try to make this part of the client bundle. So in that case, this code will go on the client side, which is actually going to blow up your application, as you can see over here. So if you really have this need of using a server component within your client components, the recommended way to pass the server component as a prop to the client component. So let's say instead of using the server component within this, I'm going to pass the server component to this client component that I have created like this. Now, when I do it like this, I can access the server component as children in the client component, and then I can render this children over here. Let's also make sure that we also have this text that says client component, and we can also get rid of this use client directive from the top of the home page because we do not really need this at this point. As soon as I just saved the file, it automatically created this example.txt file. In the browser itself, you can see that we are not getting any error. So inside of this client component, we are actually able to render this server component in the recommended way. Let me explain this one more time. The issue happened when we tried importing a server component in a client component. The solution to that problem was, do not directly import a server component to your client component. Pass your server component as a prop to the client component. So we are passing server component as a child to this client component. So that is why inside of this client component, we are able to access that server component in the form of children. So children in this case essentially represents that server component. And then we are rendering that server component over here. Perfect. Middleware allows you to run some code before a request is completed. And before we learn about middleware, let me do some cleanup. I'm going to delete this components folder, this example.txt file, and then in the page.tsx, which is actually the home page, I'm going to get rid of all of this. Okay. So middleware allows you to execute some code before a request is completed. And the way you create middleware in Next.js is by creating a file at the root of your project. And the name of this file should be middleware.ts if you're using TypeScript, or JS if you're using JavaScript. This middleware file is just going to export this function called middleware. And right now, this middleware is going to be executed for each request that comes to our application. Let's see this in action. If I just come here and refresh the page and check my console, you can see that we are seeing a lot of logs related to middleware executed. That means for any request, for example, whether it is related to fetching the icon, fav icon, or any static assets, for all of these things, we are executing the middleware right now. So if you really think about it, this actually does not make sense. You do not want your middleware to be executed for each request. So to tell Next.js like for which routes your middleware should be executed, you can export this config object that has this matcher property. And in this matcher property, we can specify that this middleware should only be executed for this about page that we have created over here, right? So let's see this in action. I'm going to come here, refresh this page, and you'll notice that we are not getting any console logs over here. But if I go to this about page, you'll notice that we are seeing this middleware executed. Since now our middleware is being executed whenever a user is trying to access this particular route. Okay, so you could imagine we could do something like this. Let's say you have this variable can access about page, and if the user cannot access the about page, we are simply redirecting the user to the home page, right? Otherwise, if the user can access the about page, we are just returning this default response. And we also need to import next response from next server. And in this middleware, we can access this request. This request is going to be of type next request that we can import from here. So now what should happen is, since this is set to false, we should not be able to access the about page. If I try to access the about page, it should redirect me to the home page. Let's see if this is working or not. So I'll come here, I refresh this page, and you can see this redirected me to the about page. But if I am someone who can access the about page, let's say, I'll come here, go to about page, and you can see I'm able to access the about page. Now, if you want your middleware to be executed for multiple routes, you can create an array over here, and then you can specify that execute this middleware probably for about and also contact route. Now, with this, you are only going to handle these static routes. And what I mean by that is, let's say inside of this about, I'm going to create another nested route. Let's call this me. And then I'm going to add a page.tsx file to this. This is going to be me page. Now let's say if our middleware is being executed or not. So right now we can see this in the console. If I try to access this page about me, it seems like that middleware has not executed. Why is that? Well, the reason for that is because we are providing static routes over here. So if we want this middleware to be executed even for all the children of this about route segment, what we can do something like this. And what this means is, if user is trying to access a route that matches with this pattern, that basically starts with about, and then here it could be anything, right? Now the star that you are seeing over here represents something, but before we see what does it represent, let's see if this is actually working or not. So right now we can see in the console, last line is compiled in 63 seconds, 91 modules. I will come here, I'll refresh this me page. And now if we see in the console, you can see that middleware has been executed. Now let's try to understand these measures. So if you write something like this, this is just going to match the about segment. Nothing after that. No children segment whatsoever. Similarly, you can do something like this, and this is just going to match about and me. But if you do something like this, this is going to match about, and the first children can be anything. Okay. And then you are seeing these special characters like asterisk, then question mark, and then plus. So question mark means 0 or 1 segment, right? So question mark is going to match 0 or 1 segment. Star is going to match 0 or more segment, and plus is going to match 1 or more segment. So you could imagine that star is more like a wild card or something. So it is going to match any number of route segments that exist after this about route segment. And finally, we can also pass a regular expression. For example, one of the really popular configuration option is something like this. So in this, we are just adding this regular expression. And with this, we are specifying that this middleware should be executed for all the routes except API routes, static files, images, fav icons, and some of the metadata files. Because for these, it does not really make sense to execute middleware. Now, the reason why we're excluding the API routes, because if you'll be implementing solutions like authentication, like implementing Next.js or something, it is required that you exclude API routes to make them work properly. So the way you would protect these routes is by going to these routes and then individually checking if the session exists. If the session exists, users should be allowed to do that operation. Now, similar to this redirect method that we have present in this next response, we also have this rewrite method. And in this rewrite method, what we can do, for example, let's say for the time being, I'm just going to say that execute my middleware if someone is trying to access the about page. This is going to make the example a little bit clearer for you. Let me get rid of this piece of code and this one also, and let's just get rid of this also. So in very simple terms, this is what we're doing. When someone will try to access this about page, we are going to execute this middleware. And then we are actually going to show them the content from the home page without actually changing the address in the address bar. So this is what rewrite method allows you to do. It is not going to change the address in the address bar, but it is internally going to change the destination for this particular request. So let's see if this is working or not. So when we try to access the about page, we should be able to see the content of the home page. First of all, let's check the home page. So this is the home page, as you can see over here. And then if I try to access the about page, you'll notice the address remains same. The address is saying that you are in the about page, but the content that we are seeing is coming from the home page. So this is what rewrite allows you to do. Now in the middleware, you can also access and modify cookies very easily. For example, in this request, you get access to this cookies object, which has this get method, and then you can specify the key. So this is going to return the cookie for you. if this exists. Similarly, you can get all cookies by doing something like this. If you just want to check that if this request has this particular cookie, you have this has method available. If you want to delete a cookie, you can do something like this. Now, similar to all of these request methods, we can do the same kind of things with this response. So first of all, we are going to generate a response, and then we can set cookie like this. And then we can send the response from this middleware. Now, similar to those cookie methods, you also have access to these headers method. For example, if you want to modify request and response headers, you can very easily do that directly within the middleware itself. For example, if you want to get a header with this key user agent, you can use the get method. You can check if a specific header exists by using this has method. You can get all the headers by doing something like this. And then you can set a header. You can set multiple headers like this. You can delete a header by doing something like this. You get the idea, basically. Now, if you want, you can directly send a response from this middleware to the client. So for example, in this, what I'm doing is right now, first of all, this is going to be executed for each request. So what I am saying is I'm simply returning a JSON response with a status code of 401. And let's say that you are not authorized to access this page. Okay. So now when user is going to access any page of our application, they are going to see this JSON response. That means you can directly send the response to the client from the middleware itself. You can also set CORS headers to allow cross-origin request directly from this middleware. So here's what I'm doing here. First of all, whenever I'm getting a request to my application, I'm just getting the origin and checking if this origin is part of the allowed origins. If it is part of the allowed origins, I'm setting the necessary response headers that is going to allow the cross-origin request for this particular origin. And for those scenarios, if the request is pre-flight, I'm directly sending this response from the middleware to the browser, let's say in this case, to signify that yes, you can make whatever request you want to make. Okay, let's talk about some of the optimizations that we can do in Next.js, starting from Next.js image component. Now, the reason why would you use Next.js image component over normal image tag is because it provides you a lot of improvements. For example, Next.js does automatic size optimization if you're using Next.js image component. It also prevents cumulative layout shift, and it also does something called as on-demand image resizing, even for remote images. Now, cumulative layout shift is a metric that measures how much the content on your page moves unexpectedly, either on the page load or when the user is actually using your application. Let's first see how you can use local images using the image component. So first of all, I'm going to import this image component from next image. Then what I can do at the root of my project, I can create a directory called public. Within this public folder, I have downloaded this pixels photo, as you can see over here. Let's rename this to something like dog.webp. All right. Now in the home page, I can add an src prop to my image component. And in here, I can specify image source like this, dog.webp. And let's also add an alt tag. Now, if I try to access my page at this point, it is going to throw me an error, as you can see over here. And it is telling me that width property is required, but you have not added it. Now, first thing first, if you want to use some local images within your Next.js application, do not pass your src like this. Instead, import that image statically, more like this, and then pass the src to this image like this. So when you do something like this, Next.js can automatically optimize this image, fetch its width and height, and then now you do not have to specify its width and height over here, as you can see. I can make this flex goal and a gap of 4 to arrange my content like this. Okay, so if you want to use local images, make sure you import your image in a static way and then pass that reference as an src to your image component like this. Now let's see how we can use network images or remote images. I'm going to copy this image address, and then within my application, I'm going to use this within the src prop. We can also get rid of this dog import statement. Now when you're using remote image, you have to specify a width and height prop to your image. Based on this width and height prop, Next.js is going to calculate the aspect ratio of the image. It is also going to reserve this much of space in the browser before this image starts loading to prevent the cumulative layout shift. And it also uses this width and height along with a bunch of other things to generate an SRC set for each image. And then browser uses this SRC set to determine which image it should load in what device size. So as you can see, our network image is working also. Now, one really important thing regarding this network image. So what Next.js does, it even optimizes these network images on the fly. That means whenever there is a need to show this image, it is going to optimize this image on the fly and then serve this image directly from our server. And that is why in the Next.js configuration file, you specify that what domains you need to allow within your application. And the way you do this is by adding this images property, which contains a remote patterns array. And this could contain a bunch of objects which has these properties like hostname images.pixels.com. Now, the reason why this is important is because when Next.js optimizes your image, it is using your server resources. And that is why you have to be very explicit about this, like what domain is allowed and what domain is not allowed. You can even go a little bit deeper than that by adding the protocol also and then path name like this to make it more specific, like what patterns of images are allowed in your application. Okay, now let's talk about some of the important props that we have present in Next.js. So as I already told you, this width and height prop is used to determine the aspect ratio of the image. This also becomes the actual dimension of the image in the browser, unless you have overwritten the width of the image using CSS. And browser also uses this width and height prop to generate an SRC set. Let me show you. So we have this image. If I try to inspect this image in the browser, you'll see this image component, and this image component has this SRC set attribute, as you can see. And now you can see that Next.js has generated a bunch of images that points to different sizes. For example, this is 1x, then we have this 2x, and then we have the default one. Now there is this important thing related to largest contentful paint. So whenever you're trying to load an image that occupies the major portion of your screen, that essentially becomes the largest contentful paint. And you can see this in the console. Next.js is giving you this warning that if you are using your image in a way that it becomes the largest contentful paint for that particular page, make sure you add the priority prop also. So if I just come to my image component and add this priority prop and I refresh this page, you can see now we do not see that error. So priority prop tells the browser to load this image as soon as possible. Now sometimes there's also this possibility that you do not know the width and height of the image. So in those scenarios, what you can do, you can actually use a fill prop instead of the width and height. So what this fill prop does is that it makes this image takes the height and width of its parent element. So right now it is taking the entire screen space, as you can see. And the reason for that is this has now become an absolutely positioned element. So what we can do, we can wrap this with a div or something. And then in this div, I can give this a position of a relative. And probably in this one, I can specify that this should have, let's say, width of 40 and height of 40. So based on this, it is just going to occupy that portion. And we can also add probably object cover or something so that image maintains its aspect ratio over here. Perfect. Another very important prop that is available to us is this sizes prop. So this sizes prop is just here to tell the browser that up to 768 pixel, this image is going to take 100% viewport width. And then from 768 to 1200 pixel, this is taking 50% of the viewport width. And above 1200 pixel, this is taking 33% of the viewport width. Browser then uses the sizes prop and the SRC set to intelligently choose which image it should load at what breakpoint. Okay, let's talk about metadata now. So metadata is an API in Next.js that you can use to inject necessary headers for improved SEO and shareability. So if we go to layout file that is present in the root, you can see we have this metadata object that we are exporting out of this file. Now this is called static metadata. Static metadata. And in this you can specify the title of your app, and then you can also specify the description, right? Now if I come to my browser and refresh the page, go to view page source, format this a little bit, you'll find the necessary tags related to SEO over here. For example, the title is doggy and the description is also here, right? So I have created this post page as you can see over here. And in this, what I'm doing is I'm just importing the post that we have present in this file. And then I'm just rendering these posts over here. So if I go to the browser, you can see this is what we have right now. So this page is essentially listing out all the posts that is present in my site. So for this page, I can export this metadata. The title is all post and the description is all post present in the database, or let's say all post related to dogs. I don't know. You get the idea. And then we can come here. We can check view page source and we should be able to see those title and description over here. Perfect. So this is called static metadata. But when I click on any of these, it takes me to a 404 page. So let's create this detail post page for now. So I'm going to create another folder, which is going to be a dynamic route. Let's take the ID. Inside of this, let's create another page.tsx. First of all, I'm finding the correct post based on the ID. If the post does not exist, I'm redirecting the user to this not found page, which is 404 page basically. And then if it exists, I'm just rendering this JSX, which is going to render the post. Okay. So as you can see over here, let's go back over here. I'll click on this and we can see this is working as expected. Now for all of these individual posts, there is a way to generate the correct metadata tags. And for that, what we can do, we can use generate metadata function. So whatever props we are getting inside of this post function, we are also getting these props inside of this generate metadata functions automatically. Okay. So based on that ID, I'm trying to find the correct post. If the post does not exist, I'm simply returning this object with a title and description that post not found. But if the post exists, I'm returning this object, which has this title and then description. So now if I take a look at the page source for all of these individual pages, they should all have the correct metadata tags associated with these pages. So if I'll just come here, so you can see the title is training your Frenchie and the description is this. But if I go and choose a different post, let's say this one, and I inspect its page source, you can see that the title and description meta tags are different here. So you can use generate metadata function to generate metadata dynamically. Now this metadata object contains other very important properties such as Open Graph. Now through Open Graph, you tell these platforms out there that this is how it should show the preview of this particular link. Let me show you an example. So if I go to Google and search for Open Graph Checker or something, and let's go to this first result that I have. Now in this, I can actually enter any address over here. And in this one, I can paste a URL like Next.js.org. When I click on this check website, it is going to show me the preview. Like if I share this URL in platforms like Facebook, this is what the preview is going to be. And this is what it is going to be on Twitter. Now the tags that are responsible for this are these tags that you are seeing over here. If you are using metadata API, you do not have to write these tags. You can simply specify Open Graph property. This is going to be an object. Then I can set the title, description, and then I can pass the images, what I want to show. So now when someone shares this particular URL, they are going to see a preview of that URL. So similar to this image component, we also have this script component that is available in Next.js. You can either add your script to your layout file or in the separate page file. So if I want my script to be available only in this home page, then I'll be including the script in this page only, right? I'll be importing script from Next script, and then I can simply include a script like this over here. This is just an example. You get the idea. Now this script is only going to be available in this particular page. But if I want a script to be available across all the pages, I can simply import this script inside of my layout file. To fine-tune the loading behavior of these scripts, you can modify the strategy prop that is available to you. Now this strategy prop basically accepts 4 values: before interactive, after interactive, lazy on load, and worker. So if I set my strategy to before interactive, this script is going to be loaded before any Next.js code and also before any page hydration. But if I set my strategy to after interactive, which is actually the default strategy, But if the strategy is set to after interactive, this script is going to be loaded early, but only after some page iteration occurs. That means if some part of the page becomes interactive, then only this script is going to be loaded. Now, if I set the strategy to lazy on load, this script is going to be loaded during browser idle time. That means when the page has been loaded, at that time, this script is going to be loaded. Finally, you can also set your strategy to worker, which I'm not going to be talking in this video because this is an experimental strategy. This is not stable yet. And also you will face a lot of limitation if you'll be using worker strategy, because what this does is that it tries to load your script in a web worker. If you want to learn more about this, you can watch my scripts video. The link to that video is in the description. Now, if you want to inject inline script, you have two options of doing it. First of all, I can include my script component like this, and then within curly braces, I can write my JavaScript within a string like this. So this is one of the ways. Okay, second way is by using this prop dangerously set inner HTML, and then in this underscore HTML, I can pass my JavaScript code in a string. So these are two ways to inject inline scripts. One important thing to know at this point is when you are injecting inline script, make sure you add an ID property, because Next.js is going to use this to optimize your script. You also have this option of listening for some events in the script component. For example, you have this onload prop available, and then in this you can pass a callback. This code is going to be executed when this script has been loaded. Now, similar to this onload, you also have this on error like this. So this is going to be executed when the script has failed to load basically. And you also have this on ready. So on ready is similar to on load in a sense that this callback is going to be executed after the script has been loaded. But the only difference between on ready and on load is on ready is going to execute this callback every time the component mounts. And one more thing, these three events that I talked about, on ready, on load, and on error, you can only use these if you are in a client component. Finally, any extra attribute that you pass to your script like this is going to be passed directly to your original script tag in the browser. Now, sometimes you also have this need of analyzing your bundle sizes so that you can optimize your code in a better way. Next.js has this package called Next Bundle Analyzer that you can use, and it is going to give you a report for all of the dependencies and how much space they are taking in your application. Let me show you. First of all, I'm going to install this dependency by executing this command npm add next bundle analyzer. If you are using npm, do npm install next bundle analyzer. This is going to install this dependency. Then in the next configuration file, we need to import the bundle analyzer. We are going to call the bundle analyzer by passing a configuration object, and this is only going to be enabled when the environment variable analyze is set to true. And then we are passing our next configuration to this instance of bundle analyzer. And now I can execute this command analyze is equal to true. This is actually setting this environment variable to true. And then I'm executing this npm build. Now when I do this, it is going to open three browser tabs for you, as you can see. In the first one, it is showing me all of the client-side dependencies, essentially the client-side bundles. And then in the other, it is showing me all of the edge-related dependencies, as you can see over here. And finally, all of the modules related to Node.js directly, as you can see over here. And you can easily zoom into any part of this to clearly see what is going on. Okay, let's talk about lazy loading now. But before we do that, I'm gonna do some cleanup. I'm going to delete pretty much everything that we have created so far. So now we just have this home page with a heading that says hello world. Now through lazy loading, you can actually improve the performance of your application, essentially initial loading of the page in case of client components. And in the context of Next.js, when we are talking about lazy loading, this specifically applies to client components. So let's make our home page a client component for now. Consider this scenario for a second. In this home page, we have a lot of components that are increasing the client side bundle size. For example, I have created this dog dialog component, as you can see over here. In this, I have imported shared CN button and dialog components. So this is just a dialog that contains some content. Okay. And this is also a client component. Now in the home page, I can import this dog dialog, and then Within this hello world, I have added this image, dog image, and then I have added this dog dialog component. This dog dialog component also contains a button through which I can open this dialog. Let me show you. If I show you this in the browser, you can see we have this open dialog button. If I click on this, it opens a dialog for me. At this point, if I try to make a build of my application and check the bundle size, you can see the home page has a first load.js of about 124 kilobytes. In the home page only, we have imported that dog dialog component. Now, if we want to improve the performance of this particular page, or let's say reduce the client-side JavaScript, we can use next dynamic function. I can import dynamic from next dynamic, and then I'm going to call this dynamic function. This dynamic function is going to have two arguments. In the first argument, I'm specifying the callback. This callback is returning this import statement, which is actually going to import this dialog. And then in the second argument, I'm specifying that the server-side rendering for this particular component should be false. And in this case, it actually makes sense when you think about it, because this is a component that is not involved with any type of SEO related stuff. And for our scenario, it makes perfect sense to set the server-side rendering to false. Now I can simply take this dynamic dog dialog instance and then use it over here like this. Then I can get rid of this dog dialog import statement. First of all, let's check if this is actually working or not. So if I go to the browser, I refresh the page and I click on this button, you can see this is actually working. But now if I try to make a build of my application again, you can see that the bundle size for the home page has been reduced to 106 kilobytes. So that's some really nice improvement. And you could imagine that if you really want to use a very heavy component in the front end, in the client side, then you can probably dynamically import that component to improve the performance of your application overall. Alright, that's all for this video. If you found this video valuable, do like and subscribe to my channel. I'll catch you in the next one.